People used to loathe birthdays, but we want you to have as many birthdays as possible, but in good health. The data does not show that you can live in bad health for very long. So if you're in bad health now, you need to do something about it. One of the last companies to measure my telomeres in Israel said that my telomere lengths were those of an early 20-year-old. So within 6 months of the gene therapy, my telomeres had lengthened by 20 years.
I want to live to 200, which I think is possible. I know that sounds crazy to a lot of people, but what they always do usually is they laugh, like right in my face. And I have to go, no, I'm real serious. Because if you get on the wave, then it's like surfing. You can go a long ways.
There's something called longevity escape velocity, and that just means that you live long enough to catch the ultimate wave into exponential aging.
200-year life. Aim higher.
Welcome to the 200-Year Life Project. This is the ultimate journey. Now, I'm Gary Leland. I'm 71 years old, and I'm dead serious about becoming the first person to reach 200. So today, I'm excited to bring on our first guest. We've done a lot of shows now if you've been following us, but our first guest, and I had several people to choose from, and I chose Elizabeth Parrish first because I thought her story was so exciting, and she's so pleasant to talk to. Elizabeth, thanks for coming on the show.
Thanks for having me. It's nice to meet again, even though it's just over the computer.
Even though it's just over the computer. Well, I felt like we made a good tie between each other. I enjoyed talking to you, and your information was so great that I'm interviewing all the speakers who were at Da Vinci 50, but I wanted to interview you first because I found your story so amazing, and what you're doing is so amazing that I wanted to let me tell everybody a little bit about you before we get on, though. Now, Elizabeth's someone who doesn't just talk about radical longevity. She puts it in her own veins. I mean, she's the founder of CEO of BioViva, a company dedicated to the extension of healthy human lifespan through gene therapy. And in 2015, I'm hoping I have all this right. You can correct me if I'm not, but in 2015, at the age of 44, she made history by becoming the first person on the planet to undergo gene therapy specifically designed for reversing aging by testing it on herself before going to anyone else. And the results were stunning from what she's told me. Your telomeres lengthened by roughly 9%. Her triglycerides dropped by half, and your biological markers suggested you had rolled back approximately 20 years of aging. And 10 years later, she's no special side effects or specific side effects that she's told me about. And she's living the life, Am I pretty right on everything I said there?
That's true. I've done a few more gene therapies since 2015, but that's true. I took 2 gene therapies, one to lengthen my telomeres to increase cellular divisions to get you to the 22, or not the 22, but the 200, let's say 222 age range. And the other one was to increase muscle mass.
So you've done 3 now? Is that the deal? 3 gene therapies? How many?
12.
So you had to go out of the country to do the first one, I think you said. Do you still have that issue?
Yeah, absolutely. So these are not approved by the US FDA. Approval takes about $50 million worth of animal research per each gene, which is ridiculous because the animal research that's required is not predictive of how the gene therapies will work in a human. We feel that humans are the best model organism, and all the basic research in animals has already been done on these gene therapies.
So, do you go to a regular doctor, and when they see your blood work, do they just they go, "What in the heck? What's happening here?"
My doctor's a functional medicine doctor. She's aware of the gene therapies I've taken, and sometimes she just throws the results, my blood work results, at me. She usually, she comments. And she says, basically, unsurprisingly, I have almost no inflammation in my body and markers look great. So that's been fantastic. And it's nice to have a doctor that you can confide in and let them know what you're doing in your free time.
Very, very much so, especially in your situation, I guess. Hey, explain to me gene therapy like I'm a kind of smart 10-year-old, for viewers out here who might not be familiar with this.
So gene therapy is the addition, deletion, or editing of the human genome of a subsequent gene. So how we do gene therapy at our company is we take a therapeutic gene, a gene known to make humans healthier, and we deliver it to the nucleus of the cell, but we don't modify your human chromosome. We leave it alone. Other gene therapies you've heard of that do that are things like CRISPR, and they're delivered just like our gene therapies are, but they have the ability to modify the human chromosome. We can also use gene therapy to delete genes out of your chromosome, and we also do that with CRISPR. So it's the modification of the genes within the nucleus of the cell.
Okay. And like when you started, you targeted two things: myostatin inhibitions for muscle and telomere lengthening. Why those two first?
Yeah, so the reason we did, there's a gene called, it's a big name, telomerase reverse transcriptase. And what it does is this single gene, remember, all the genes in your chromosomes code for proteins, enzymes, or hormones. And that's why you have the traits that you have. First of all, your whole human genome makes you identify as human. And then the differences in the way that your genes are transcribed are the differences between people, between our fingerprints, our eye color, our hair color, and our disease risk. So the reason that we chose the first two gene therapies is one of the biggest limits to human lifespan, living beyond 120, would be the rate of shortening in our telomeres. When our telomeres, these are the caps at the ends of every chromosome, have telomeres. And when those telomeres get short, our cells can no longer divide. And us and 23 other species are limited by how fast our telomeres shorten. So dogs and cats and other organisms are also limited by telomere shortening. And that is what defines the lifespan of the organism, the absolute longest lifespan. So many of us die long before we get to, let's say, the beneficial, most longest lifespan of humans, because of our lifestyle. So lifestyle and our genes can affect us in here, but our absolute lifespan would be about 120 if we were most conservative with the telomeres, the telomere shortening at the ends of the chromosomes. So what gene therapy gives us the ability to do is lengthen the ends of the chromosomes, the telomeres, so that we have more cellular divisions. The other gene therapy is a gene called follistatin. That one had some safety and efficacy already done on it with children with Becker's muscular dystrophy, and it increases muscle mass. Now, it does not cure muscular dystrophy. In muscular dystrophy, a gene called dystrophin is related to the breaking of the muscles. So children who don't have dystrophin don't have the elasticity in their muscles, and when they use their muscles break, and eventually heart tissue can break as well. Follistatin increases muscle mass. So where it did work in these children to make it so they could walk farther and they did have bigger muscles, it didn't solve the dystrophin disorder. But it was considered safe and effective for increasing muscle mass. Now, the decrease in muscle mass, or something that eventually is called sarcopenia, is the clinical diagnosis when we get older and frail. So we repurposed this gene therapy for an aging population. So the two of them together, we felt were very synergistic. One that was going to push muscle growth, which pushes cellular division, the other one that was going to take care of the cellular division problem.
So, from what I understand, critics said your early telomere results were within the margin of error, and then you published peer-reviewed data in 2022 about that. What did that show?
So that showed that if it was within the margin of data, they had already. So within 6 months of the gene therapy, my telomeres had lengthened by 20 years. And if that's in the margin of error of any of those companies, that would mean those companies were absolutely worthless. So number one, they would have been stepping on their own toes. I think that the world of these scientists were interested in stopping these tests because they had hung their hat on that lengthening telomeres could cure all of aging, and we were about to show whether or not it could or not. So I think they wanted to discredit what we were doing. Since the first telomere test and the last telomere test, my telomeres have lengthened by over 5 years for every year that I have lived, which is well outside of their margin of error. And we have continued to use those companies and other companies. At times, we've used up to 3 different third-party companies to ensure that these telomere lengths are accurate. One of the last companies to measure my telomeres in Israel said that my telomere lengths were those of an early 20-year-old. But I have to give you the disclaimer, the only cells that we test are the white blood cells. So that does not mean that the telomere lengthening has reached every area of my body. And so we continue to learn how to redose that therapy to layer it into the system. So yeah, we had a big outpouring of scientists and people who make their money other ways than saving lives. And our response to that was, we'll wait and see. If that's within the margin of your errors, your test has a major problem.
So, yeah, for sure. I mean, yeah, 20 years is a big deal. I'll
I
take
mean,
that
20
right
years
now.
is alive or dead for most people who,
Yeah,
are over a certain age.
yeah, I'll take that in a heartbeat. I mean, I wouldn't do too much complaining about that for sure. So you said a few minutes ago that the longest, maybe not exactly, but basically the longest a person could live because of their telomeres shortening would be about 120 years. So that means you now have a chance to go 140 years.
Or more. So when we do the gene therapy in a dish, it's called ex vivo gene therapy or in vitro being the dish. Let's just picture it that way. When we do the gene therapy on those cells, they can divide an enormous amount of times. And it's called immortalizing a cell because its ability to break normal cellular divisions lies all within those telomeres. So if we were able to give people gene therapies and then they took these gene therapies maybe every 5 years or so, if as long as we can keep those telomeres long, there may not be a bottleneck to cellular division. Now, there will be other problems that we have to solve. This just lifespan isn't all we want. We want health span too. So we need to make sure that the rest of the cellular function is there.
Right. One of the things when I tell people that I want to live to 200, which I think is possible. I know that sounds crazy to a lot of people, but what they always do usually is they laugh, like right in my face. And I have to go, no, I'm real serious. And then they say, well, I wouldn't want to live to 200. And I go, why? And I said, well, I wouldn't want to be like in a walker or a wheelchair that long. I'm like going, I don't plan on dragging a wheelchair with me. I mean, the health span is a vital part of that. I mean, who wants to live all sickly for 50 years? Or
Yeah.
100 years or something.
People who generally want to live longer are people who have been diagnosed with their last diagnosis. And so I take it very seriously when other people put limits on your or mine or my children's potential lifespan. Because what they're saying is at some point, they think life isn't worth living. But if we can make you healthy and keep you healthy, then it would be worth living. And if they want to take a bet and roll a dice and decide to die at a certain age when people may be well surpassing them in good health, let's let them have to do that. I'm certain that won't be their choice as the science is proven out.
I think you're correct. Let me ask a question about the statement I made just a second ago, about, you said average lifespan a person could live to 120 and that you've been able to add 20 years worth of time basically because your telomeres, you added 20 years to it. So in another 20 or 30 years, could you do the same gene therapy and add another 20? I mean, could you keep doing that same therapy every 20 years is basically what I'm saying. Lengthening your telomeres over and over and over.
I think that would be the point. I have done that gene therapy more than once. I did it a second time, and you'll see it on that published paper. You'll see a jump in my telomeres that definitively happened right after the therapy. And then the telomeres, again, continue to slowly lengthen. So I think the key to these therapies until we can target every cell in the body. So, okay, let's like differentiate gene therapies. There are gene therapies like lengthening telomeres that have to be put into every cell of your body. And our technology is limited. Today's best technology cannot get a gene into every cell of your body. There are cells that sit on the ends of very small capillaries and things like that. And the gene therapy is definitely absorbed and excreted from your body rather quickly after being administered. Your liver takes it up, your lungs take it up, your kidneys flush it out. So we're still learning how to break that bottleneck. But there are other gene therapies that you do not need to get in every cell. And that's things like follistatin and clotho. those gene therapies you could just put in your muscles here and here, and you would have a full system benefit from them. So there are two different type of therapies. There's autocrine and paracrine. One of them does not share the protein outside of the cell, and it's a limit of the therapy itself. The other one does share the protein outside of the cell and benefits the whole body, even if a smaller area is targeted.
Okay. So let's move on to BioViva. Where is BioViva today compared to where y'all were in, let's say, 2015? How far has the science moved?
You know, I think that we are actually the fastest moving gene therapy company in the world. We just came out with a dual gene therapy for liver regeneration, and it's already in 2 people, and that was this year. But as far as, and we have patents, but as far as how fast we've moved, I think that we've moved incredibly slow. So when people look at us and they say, wow, you guys are like biohackers, you're moving so fast, it's really not true. It took us 2 years to decide to use the first 2 gene therapies in my body in 2015. It took 5 more years to make the dementia therapy that we did publish on and got the patent for this year. And that paper came out in like 2021, 22. It took us 6 more years to do the next 2 gene therapies to regenerate the human liver. So we are working at a pace that if you had institutions and largely funded companies, you should be able to work at 3 times that pace, if not 4 times that pace. But we are the fastest moving gene therapy in the entire world, working on a fraction of the allocated resources, just moving in a humanitarian mission to move these technologies as fast as we can with as little as we have.
Well, so it's not fast enough for, in your opinion,
No.
but that's just how much time takes.
No, because when the story launched that I had taken the first 2 gene therapies to treat biological aging in 2015, that's over 11 years ago, people rushed to us to help solve the aging problem. And since then, 36 million people have died of aging every year because we need funding, we need support, and we need advanced research in larger institutes. And the system has been vastly resistant to that because it's a pharmaceutical system. So going to this system and asking to cure disease is like going to big oil and asking to put in renewable energy. It's not their business.
Right. Same putting in electric cars.
Exactly. So we have moved as fast as we possibly can in a humanitarian mission to help as many people as possible. So, for what we've done is quite amazing, but what we could do would be exponential.
So I believe when you were talking at Da Vinci 50, you said y'all have had a lot of, maybe not a lot, it's the correct term, but y'all have had test subjects. You aren't the only person now who's done the test, but it's like super expensive at the moment. I can't, for some reason, I'm thinking in my mind, you said like $1 million to do this, but I could just be daydreaming. But it's actually,
but yeah, it's less than that. So over 300 people have participated through licensing partners. As a U.S. company, we cannot treat patients, but we can license the technology out to where they can legally treat patients. And over 300 patients have been treated. And it runs under $500,000 for a full large dose gene therapy, but most people want multiple gene therapies. And so that can gain in price quickly. But we are doing so right now. We're opening up funding to buy a GMP facility that would be able to make a gene therapy, a large dose gene therapy, GMP for $20,000. And I know that sounds like a lot for people, but for us, that's like almost a miracle.
well, compared to $500,000, it sounds like it's on the sale to me. I mean,
Yeah, and if you look at the U.S. approved therapies, they run from $2 to $7 million. So already we have gotten the prices way down. With this, we would be where maybe even insurers with unapproved therapies would start approving them for payer use, meaning insurance companies could start covering them because they would have enough human data to be a better alternative to other therapies.
well, with these therapies, if you were not on your deathbed, but let's say you were pretty sick, you knew you had like a year or so to left. Would this help in that situation, or is this something you got to take while you're still healthy?
We would hope that it would help. So, our licensing partners open up to all scenarios because people of all different levels or degree of health concerns need access. I believe that the best use of the medicine in the future will be prophylactically. It'll be used like an immunization after the age of 45, and you'll start getting your gene therapies to protect you from the ravages of time.
Okay. So what do you think is the most exciting thing, single most exciting things you guys are working on? Because you're working on a lot, it sounds like to me.
Well, the single most exciting, I mean, right now we're really excited about liver regeneration because it would qualify a lot of people who otherwise could not get access because they have fatty liver disease. It also could be a replacement for GLP-1 agonists, which we really greatly need. People are going to have muscle loss and bone loss from these extreme diet solutions. And so we would like to be able to meet that. But I really can't say that one gene is more important than the other. We can't really pick a team. We have to realize all the genes are on the same team to treat aging. And so I think getting, obviously raising the money to get the cost of the gene therapies down, that is super exciting so that more people can access them. That would probably be up there with something I would consider very, very important.
Yeah, that sounds pretty exciting to me. So I know you don't know a date, but is that like a 2-year deal, a 10-year deal to get that going?
If we could get the right investor, we could have the affordable gene therapies within a year of making the investment. So it would actually work quite quickly.
Okay, so once you got the capital, you can do it
Yeah.
quickly. Okay.
Yeah.
Okay. So does AI, right now AI is into everything. I mean, literally everything, and it's only been out like a year. I don't know where it's going to be at in 10 years. It's already in everything. Does AI have a lot, I guess, is it helping accelerate what you're doing?
So we have built a system of all known gene therapies, and we're building a system that then incorporates all of the GWAS data, and then we will actually build a system to interpolate the human genome person by person to create precision medicine. So we are actually working on our own AI system so that we can more quickly identify combinatorial gene therapies that each person would need to treat their biggest disease risk states and treat biological aging. And that's been exciting. And then in order to do that, we had to prove that we could build an AI system. So you might remember I shared something called Trial Atlas. It's trialatlas.ai.
Yes, I've
That
gone
just
on that
helps.
several times.
Yeah, that just helps people get access to clinical trials, which could be life-saving in the interim while we bring the prices of these gene therapies down and get more safety data.
And that's at trialatlas.com, right?
Well, .ai. Yeah,
.ai, okay. Yeah.
yeah.
That was
So
pretty good.
yeah, yeah, it is, and it showed us that what we could do, and then now we're doing internal LLMs and a whole lock key system so that researchers will also be able to access the ability to create combinatorial gene therapies. We never started with a single gene therapy. We were always a combinatorial gene therapy company, and that's what is going to be important to treat complex disease. So in the world of monogenic disease, meaning mono meaning one, genic meaning genetic, people with a single gene mutation, there are a lot of treatments out there now, 13 approved treatments through the FDA to treat those conditions. And that was a great testing ground, but in order to treat biological aging at the core level, we need combinatorial gene therapies. And so maybe this can take that first 2 years, the next 5 years, and the next 6 years and turn it into, a 6-month on-ramp. We'll still have to double verify with human eyes that what it's come up with is something that would be beneficial to humans, but having that system is going to help us a lot.
Gotcha. So let me tell you, because of AI, when that came out last year, that's when I started getting on this 200-year deal. I really always thought my kids who were 38 and 39, I always thought they would live a long time because of technology. But I thought that Kathy and I had completely missed the wagon. We were like the generation before, longevity came out. But I felt with AI, then that changed the speed of which stuff would come out. And my thoughts, and I've heard this repeated by other people now. And every time I do it, Kathy nudges me and goes, "Hey, that's what you've been saying." Is I kind of feel like, I'm not going to go from the average lifespan of 80 or whatever to 200. But I felt like it would come like in waves, and we get a wave comes through, and all of a sudden it goes from 83 to 103. And during that 20 years, stuff happens that makes it go from 103 to 120 years. So it's really important to get on that first wave. Because if you get on the wave, then it's like surfing. You can go a long ways, but if you don't get on the wave, well, the wave's gone by, and you got to wait for another one and hope it's a good wave that comes by. Is there anything to what I'm saying here, or am I just like talking from crazy town? I mean, is there any thoughts? What do you think of my hypotheses?
No, I think that's absolutely true. I can't remember. I know that Aubrey de Grey also said it, but someone said it before him. But there's something called longevity escape velocity. And that just means that you live long enough to catch the ultimate wave into exponential aging. And it's kind of probably sounds counterintuitive to some people because, people used to loathe birthdays, but we want you to have as many birthdays as possible, but in good health. And actually, the data really doesn't show that you can live in bad health very long. So just to put that out there for people who are watching who think that ultimate longevity is just living longer in bad health, the data does not show that you can live in bad health for very long. So if you're in bad health now, you need to do something about it. The data shows that in good health, you can live a long time. And so that's what we're trying to do with genetics.
And that has been my thought also. Not that I'm a scientist or anyone smart. I'm just an old boomer that's having a good time trying to live longer. But, I've had to quit drinking when I saw how bad drinking was for you. I had quit smoking years and years ago, but I quit drinking now. I work out every morning. I'm not like pumping 500 pounds type weighting, but I'm doing exercises. I'm doing things I never did before. And oh my gosh, I was telling something the other day. If people knew how much better it feels to be healthy than unhealthy, they would all get off the wagon automatically. They just don't know, I think, unhealthy people how much. And it doesn't take that much. I don't really do that much, but it's like a lot of things I need to do, I guess is the best way. So you need to stay healthy if you want to have a shot at getting on this first wave.
Yeah, and you are doing everything right. So data would tell us that lifting really heavy weights is bad for your heart. Okay. And you do not want to blow your heart valves out. And we've seen that time and time again with extreme sports persons. So keeping your muscles active, keeping your body active are important, but high impact sports are not necessarily great. Being super skinny is not great for longevity. Being grossly obese is not great for longevity. You want to find that middle spot. You do certainly one of the greatest expanse in lifespan that you can do. If you want to expand lifespan, you do not want to smoke or drink alcohol. So there was a study in Wales, and the greatest recent lifespan expanse was the cessation of smoking. It was 6 years on average for the average person, 6 years. If you cured all cancer for people who are old, all cancer, they would only live 2 to 4 years longer because you haven't cured cellular aging. So just think about that. If you want to have this great expanse of lifespan in your middle years and health span along with it, do not smoke and do not drink alcohol. And I wish somebody would have told me that when I was younger. But
Same here.
I certainly had fun with that. But yeah, it's actually very detrimental to your health. It's a poison. They're both poisons.
I think I just got through with was it Dr. Rosen who was at our event?
Yeah.
Yes, he's a great guy. I just finished his first book that he wrote, and I love that book. And he'll be on the show in the future, by the way, everybody. But I love in his book because he does like you just did. He lists all these things. If you quit smoking, you add 6 years to your lifespan. If you brush your teeth and floss heavily every night, you add 2 years to your life. I mean, that's not necessarily the number, but he has all these things. If you wear your seatbelts, you live an extra 1 year on average. I mean, it's just crazy, all this information he has there. And it's in such a short, simple to read book that I just really enjoyed that. So when you said the 6 years from smoking, I think that is his number he has on there is 6 years. So that's great. Gosh, I have really enjoyed talking to you, and I really appreciate. Is there anything that we didn't cover that you think that we need to make sure and get in there, or anything you want to say? I'll give you a chance in a minute to tell people where they can follow you or find out more about you. But just curious, before we go to that, is there anything that I might have missed you wish we'd covered?
Well, I guess I could briefly talk about the different genes that we use and how they work and what they work on. That might be
Yeah,
interesting.
sounds great. Sounds great.
Okay.
So tell us about the
So,
different genes you use and what you work on.
yeah, so, telomeres, we've talked about that. That's to lengthen the caps at the ends of the chromosomes to give you more cellular divisions. Follistatin is to increase your muscle mass and help your metabolic system. It increases insulin sensitivity to increase your muscle mass, and it has a myriad of protections, neuroprotections. It helps with brain plasticity and all systems benefits. Alpha klotho. Alpha klotho is a gene that we just got a patent for. It is for neurocognitive typically. So we use it in cases of dementia, but we also use it to help protect the cardiovascular system and protect the kidneys. And PGC1 alpha we use for mitochondrial biogenesis. So it increases the number of mitochondria in your cells. And then we just used two new genes that we can't talk about yet until the provisional goes in. Uh, they regenerate your liver. And one of them is actually connects to a feedback loop in your brain that helps you with food satiation. And it also metabolizes fat. So instead of doing GLP-1 agonists that could be very unhealthy for your body because they keep you from desiring food. And when you don't eat, your body eats anyway, and it will eat your bone and your muscle. This gene specifically helps you burn fat and maintain muscle and bone. So those are the different genes that we're using and the different reasons that we use them.
Oh, you've got a lot of stuff you're working on at the center. How many patents do y'all have?
We have several pending, and we have two that have been awarded. Follistatin, telomerase reverse transcriptase, and klotho are all covered within those patents.
Wow, that's exciting
And
stuff.
for
This is
human
exciting
data.
technology, huh?
Yeah, it is. It is exciting technology.
Very exciting. Now, where can people follow you or keep up with you or keep up with BioVia? What's the best way for them that are interested?
So you can find BioViva at bioviva-science.com. We have social media. I have personally a LinkedIn under Liz Parrish. I'm not on these very much. I'm on Instagram and Facebook. And usually on my personal pages, I just share my personal life, but not very much of it. I'm not an influencer. I don't care that you hear my opinion all the time. I'm just trying to create drugs that extend your human healthy lifespan. But I do share a lot of value added pieces. And so if you follow me on LinkedIn or my professional account on Facebook or BioViva, you will get almost everything that's up to date that's happening this week, next week, or last month in gene therapy. And that's all companies working on this and all research. And you will really find a world that you love, I believe, in there, because in those papers lies your human enhancement and your future.
I'm excited about that. I'm going to follow for sure. And I recommend everybody else do the same. Well, Liz, I really appreciate you coming on the show. I've enjoyed seeing you again. I hope that we run into each other again at a conference in person somewhere. Yeah, I'm sure we will somewhere. Now that I'm into this full time, it's like my job now. Being healthy is a job, though.
Yeah, it is. And I hope that you go through one of our licensing partners and become a patient. I think that, if you decide to do that, nobody has to do that. I'm not here to pitch anything.
I'm definitely
But if
planning
you
on doing
decide
it.
to do that, that's fantastic.
Soon as especially if it hits $20,000, Kathy and I probably gonna be there first day. Flying into wherever it is. So yeah, I'm definitely
It'll be
interested in
that
that.
plus hospital. It'll be that plus
Yeah.
hospital plus doctor's fees, but it'll
Well,
be affordable gene therapy on the planet for sure.
at our age, we can't like mess around and wait for it to get much lower than that. We got to go for it when it gets to that kind of pricing. Half a million, kind of hard to stomach that. If so, I think I got definitely got 5 years. That's why I asked that question. How long do you think it's going to take? So hopefully you find a big investor soon. I appreciate you
Yeah,
coming on the show so much, and thanks.
thank you so much for having me.
200-year life. Aim higher.